Okay, all right, so we've got the eudiometer. It's all prepared, ready to go. It's got the magnesium, it's got the acid in it, and I'm just gonna simply just tilt it upside down and we're gonna let the chemical reaction start. So, finger over the opening, flip this upside down, get it down into the water. I can take my finger off. Just gonna lean it in there. You'll see the acid drifting down to the bottom of the tube. And we're actually gonna try to capture the whole process of it filling up with hydrogen gas. And we might kind of switch back and forth a little bit. I mean, while it's reacting, we're gonna go ahead and maybe grab a few other measurements as well. And I know that one of the things that we're gonna need to do is get the temperature of the water trough. So I'm just gonna kind of hold the thermometer in here and hopefully you can get a good reading off the thermometer. And if you switch over to the eudiometer tube, you see some excitement going on over there. And kind of like, I don't know, have y'all ever done like those Alka-Seltzer tablets where it kind of, you know, does all that fizzing? That's what it kind of reminds me of right there. And you can kind of just see how it's just filling up the tube with hydrogen gas. It's gonna take, might take a minute or two. While it's reacting, we can do some other measurements. We can do the what the current atmospheric pressure is again. And like Dr. C mentioned, okay, you got all these little scales, all these numbers here, but we want the millimeter of mercury right there. You'll see how it's got the 720, the 730, and it kind of goes all the way around. And so the white needle that we have, you'll see it's in between the 760 and the 770. So you need to estimate what the value of that white needle is right there. And that will be the barometric pressure in millimeters of mercury. And then we also need to get the density, sorry, not the density, the vapor pressure of water. And so on the thermometer, you saw what the temperature of the thermometer read. So based upon what you saw, you look over here in this column and you need to correlate the temperature you saw with what the water vapor pressure was. And it's measured in torr. Should I tell you the significance of torr in millimeters of mercury? Nah, I'm gonna save that for lecture or maybe for yourself right here. But anyway, we've got the water vapor pressure. Let's go back over here to the eudiometer tube. And wow, that was fast. It's like it's already done. I mean, that's what, maybe 2 minutes at most? And there's no more bubbling going on in the eudiometer tube. It is done. And I'm gonna go ahead and carry on to the next measurements, whereby we take a look at the meniscus of what we have right here to try to read that meniscus accurately. So I'm gonna go ahead and grab this, get my finger underneath. This is the third time I've done this now. My sleeve is not wet, just saying. All right, so I've got it handled correctly, and this kind of bothers me a little bit that there's a lot of like air bubbles stuck on the side. I mean, those air bubbles stuck on the side, do you think that's gonna affect what this meniscus is gonna read? And I think it might affect it a little bit. So what I'm gonna do here is we're gonna see if this one here works any better than the first one. Maybe it will, maybe it won't. But I'm actually kind of gonna do this right here, and this is, in theory, I'm gonna try to collect all the hydrogen gas together so that it's all in one thing. And as you might notice, you know, there's no more bubbles. Well, now there's a few bubbles stuck to the side, but you know, not as much as it was. But now I'm going to put this into the graduate cylinder. Notice no sleeve wetness there. It's getting down in there. I've got it released. And you know, I'm going to do this here for you right quick. I'm going to move this tube up and down. And as I move it up and down, do you see how the meniscus changes its level? And so that's why it's critical that we want the pressure of the hydrogen in the tube to be the same as the pressure outside in the room. And so this is why we slowly lower it down and try to put it in a position so you can see it on the camera better. and I want to try to lower it down. And you know, and ideally what I would want is I would want the water level of the meniscus to match up with the water level in the graduated cylinder. And I don't know, hopefully you can read that. It might give us just something a little bit better. It's kind of hard to say, but I think we've got a reading for this right here. And this pretty much finishes up this trial. We can move on to trial number 3 now.